In tonight's Medical Watch, a standing wheelchair. It's not the first of its kind, but it will go where no others have. It's a project 5 University of Wisconsin at Madison students embraced. More than 1,000 hours in the making and a chance to change the life of a surgeon no longer physically able to do his job. The scene, a university engineering lab, a stark concrete space filled with circuitry and metal. But despite the setting, what takes place here is wholly human.
We'll be here until 1 or 2 a.m. sometimes at night working on this project, just trying to get everything right.
I just want to try and power it up.
A mound of wires, metal bars, giant bolts, and sturdy wheels make up the base of what these students call SPOT, Standing Paraplegic Omni-directional Transport. In other words, a wheelchair that will allow a paralyzed person to stand. But that's oversimplifying things.
Most of the components in the base are made out of metal, specifically corrosive resistive metals, because there will be water and antibacterial agents that will be placed upon the base in surgery.
This device is heading to the operating room, not to support a patient, to support a surgeon.
That is amazing. That's absolutely amazing.
Dr. Cuppels checks in via Skype. It's how he stays connected with the team of students who may just end up changing his life.
I mean, I can't tell you how excited I am.
The excitement is a welcome diversion for the orthopedic surgeon who damaged his spinal cord and lost the use of his legs after a fall from a third-story balcony. The injury put an end to his career, but his story gave rise to an idea fit for a team of budding biomedical engineers.
Like if they had some sort of mechanism to keep him upright and stable, that he could possibly work in the operating room again.
The seemingly simple solution got their wheels turning.
I never expected it to be something on this scale.
The scope of the project has taken Dr. Cuppels by surprise, but it's exactly what the team's faculty advisor expected from his talented students.
When they latch onto a design project, they just can't give up. And for one credit, they're ready to put in like hundreds of hours.
You know, it's reason why probably all of us became engineers.
But this is like direct contact. So we get to talk to Garrett, we get to understand his problems, and we get to solve those problems for him. It's just, it's like fulfilling. It's really fulfilling.
And time consuming.
Living and breathing this project and neglecting a lot of classes for this. Yeah, I should be in a lab right now.
Instead, Michael Konrath is here, performing the mundane but critical task of testing circuits. It's a process that began last September in a notebook. In January, they started fabrication. Today, it's tangible. But there have been learning curves along the way.
I really had no idea how complex it would be. He needs to be very mobile. He needs to be very precise. He can't take up a large footprint.
It's not just sitting in a lab and making a device, but talking to companies, talking to hospitals, actually visiting and seeing some surgeries.
Outfitting the device to meet hospital safety standards has been a significant challenge.
One thing we didn't know at first was that he couldn't be moved by a nurse. Our first designs were not even electrical. And then we found out that's kind of unacceptable for the operating room.
With some serious hardware in hand, much of it donated, the students started assembly.
I'd say we spent, months just working on the circuit part alone.
A motion controller integrates joystick movements with the brakes and 4 separate motors. Each one controls a mecanum wheel, able to maneuver in multiple directions.
Let's try it.
Once the team adds a stability bar, they plan to perform test runs with Dr. Cuppels.
That is our main goal within our design group, but I mean, as long as we're here, like, why stop?
This is really very powerful stuff because of the motivation which is behind this project. I think they're beyond a passing grade at this point.
For these students, the project won't end with a grade on their transcripts.
We're making a device that's going to turn around a person's life.
I'm just seeing all the hours we put into this just kind of come to life.
We have this opportunity to help one person, and now we want to see how far we can take it.
And that's why the students are reaching out. They want to hear from others who have ideas about their project and how to take it well beyond their university's engineering department. Not only to navigate an operating room, but to adapt the design for other professions as well. If you'd like to learn how you can help, go to our website, wgntv.com.